Finding the GCF. Well, what does GCF mean? It's basically the greatest common factor. So how do you find a GCF? By basically finding what the terms most have in common. So what is this GCF of the following scenario? Notice I have my picnic basket and there's Coach Thompson's picnic basket. Notice there's certain things that we have in common, so we're going to identify them by circling them. I notice that I have one water bottle, he has a water bottle. I have a thing of strawberries, he has one of strawberries. I notice that I have two Cookie Monster cupcakes and he has two Cookie Monster cupcakes. I also notice that we have two sub sandwiches together. So what is our GCF? Let's see. Our GCF is going to be one water, one strawberry, two cupcakes, and finally, two subs. Notice that's the greatest amount of what we have in common. That's the whole point of finding a GCF. Now we're going to create a factor tree. So notice I have three different numbers, so that means three different factor trees that I'm going to do. So we're going to write the factors, which in other words are what are the numbers that multiply to 21. And we're going to list them all out as far as we can go. Now, so for 21, notice I started off with 7 times 3, because 7 times 3 does give us 21. But can you break down 7 or 3? Notice the only option you would have is 7 times 1 and 3 times 1. Okay, so that's already factors as low as it can go. Next one, 32. 8 times 4 gives us 32. Now 8, I can break it down to 4 times 2. Okay, notice 4, you can break that down to 2 times 2. Notice I have another 4 here, which I can then break down again to 2 times 2. So notice this is what our factor tree should look like. Let's try the next one, 42. 7 and 6. 7, I know, is only going to be 7 times 1 because no other numbers multiply to 7. But 6, we can break it down to 3 times 2. Notice I don't have to go another step further. I don't have to write 3 times 1 and 2 times 1 because we understand that. So technically we can always stop right here. Alright, now we're going to create a factor tree and then we're going to find what is the GCF for the following three numbers, 36, 16, 24. So what is their greatest common factor is what we're going to find. Well, let's do our factor tree first. Notice I have 36 and I broke those down to 6 times 6, because that gives us 36. Now, I'm going to look to break down 6. 6, I know I can break down to 3 times 2, and the other 6 also can be broken down to 3 times 2. Alright, so let's go to the next number, 16. Two numbers that give me 16, when I multiply them are 4 times 4. I know I can break down 4 to 2 times 2. So that means I can break down the other 4 also to 2 times 2. Now let's look here. 24. Notice it's broken down by 6 times 4 gives us 24. So I can break down 6 by 3 times 2 and 4 by 2 times 2. So we're looking to see what are the numbers that they have that are in common. So that means they all have them. And what we can do is we can circle them. So we can easily identify them. Do they all have the number 3? So notice I'm not really paying attention to these numbers, right? I'm looking at the ones that I broke them down to. Do they all have a 3? Nope. I notice that they all do have a 2. And coincidentally, they all have another 2. Alright, well, I know that 2 times 2 is 4. So therefore their GCF, their greatest common factor, is 4. They all have a 4 in common. So we basically are looking for what does each term have in common. Okay, so remember a term is like, basically a monomial. So we're looking to see what do they have in common. So we're going to factor out the GCF of each polynomial. We're basically going to circle what they have in common. So let's see, the first term I have is x squared y cubed z. And the second term is xyz. Notice I know the difference between the two terms because they're separated by that plus sign. Alright, so let's expand this, which you should remember when we learned about exponents. When I see x squared, it really means that I have 2 x's. When I see y to the third power, it really means that I have 3 y's. And then z doesn't have an exponent, so I know it's just a z. The next one, xyz, notice there's no exponents. That one's pretty straightforward, right? xyz. Now let's circle what they have in common. They have an x in common, have a y in common, and we have a z in common. So what that tells me is that x, y, z is a GCF. That's what they all have in common. Now to rewrite our answer, okay, x, y, z goes on the outside of the parentheses. Because they use a plus sign goes in the middle. Now, what we didn't circle goes inside the parentheses. So what did we not circle in the first part? An x and a y squared. So that's x and y squared. Notice on the bottom part, we circled everything. So what we have to have there is the number 1. So that would be our final answer. Alright, let's look at number 5. X cubed y, x squared y. Notice it doesn't matter if they're positive or negative. That's irrelevant. We're just trying to figure out what do they have in common. What is their GCF? Alright, so the first one, x cubed, means I have 3 x's. And then I have that 1 y. X squared, that's 2 x's and 1 y. Let's circle what they have in common. They have an x in common, another x in common, and a y in common. So the GCF is x squared y. When we rewrite it, the GCF goes on the outside of the parentheses. We're going to have a minus sign in between. What did we not circle in the first part? An x. We circled everything in the second part, so remember, we make sure we carry the 1. There's our answer. Alright, we're doing the same thing, but notice this time we have coefficients involved in our terms. So let's look at the first one. We have 5x, and my second term is 15y. Alright, so numbers that multiply to 5 times 1, and then I have just an x involved. What are numbers that multiply 15? 3 times 5, and I have a y. So let's circle what they have in common. And we can see that they have the number 5 in common. Is that it? Yes. So therefore the GCF is 5. Remember, when we rewrite it, 5 goes outside the parentheses. The symbol inside our parentheses is a plus sign because I get that from the original problem. What we didn't circle goes back inside the parentheses. The first part is a 1x, or just x, plus 3y. So that would be our final answer. Number 5, same exact concept. I have 3x squared, and we have 9x. Remember, negatives doesn't matter. Not paying attention to that. 3x can be 3 times 1, x squared, xx. Numbers that multiply to 9 are 3 times 3. We can't break those down, so that's it. And then you have an x. Circle what we have in common. We have a 3 in common and a x in common. So the GCF is 3x. When I rewrite the problem, 3x, because that's the GCF, goes outside the parentheses, using a minus sign, because that's what we have originally. What goes inside the parentheses is what we didn't circle. So in the first term, we didn't circle a 1 and an x, so 1x, minus. Second term, we did not circle the 3, so there's our final answer. If you ever think you didn't do something right, notice we can actually do distribution here to check ourselves. So for example, let's say I'm not sure if I did this part right. Let me just distribute it and see if we get that same answer. 3x times x is 3x squared. Notice, let's look up here. Is that what we have? Yep, 3x squared. So far, so good. Now what about 3x times negative 3? Negative 9x. Let's look to check. Is that what we wanted? Yes. So notice we did do this right. There's your answer. Alright, same exact concept. Notice instead of having 2 terms, we actually have 3 terms on these ones. So same idea though. 6x squared equals 12x and 21. Alright, 6. 2 numbers multiplied to 6 are 3 times 2. X squared means I have 2 x's. 12. Numbers multiplied to 12. 3 times 4. But remember, 4 can be broken down to 2 times 2. Okay, check yourself. 3 times 2 is 6. 6 times 2 is 12. Alright, we're good there. And notice there's the x. 21. Numbers multiplied 21. 3 times 7. Is there any letters? Nope, so we're done. What do they have in common? They all have the number 3 in common. Is that it? It looks like it, so therefore the GCF is 3. So let's rewrite the problem here. 3 goes on the outside. Notice we're going to have 2 parts on the inside. Plus and plus. So what's left over is what we write inside. So for the first term we have 2x squared. In the middle term you have 2 times 2, which is 4, and an x. And lastly, the 7. So that would be our complete answer. Alright, so number 7, notice we have first term is a. Then we have 8a squared b. And then you have ab. Well, a is pretty simple. It's just a. 8, we can do 2 times 4. But remember, 4 is really 2 times 2. A squared, a, and then b. AB is also pretty straightforward, A and a B. So what do all 3 have in common? They all 3 have an A. So that is the GCF. Remember, the GCF goes outside of the parentheses. Inside the parentheses, we're going to have 2 symbols, a plus sign and a minus sign, and I get that straight from the problem. So let's see, what we don't circle is what goes inside the parentheses. What's left over on the first term is nothing, so we put a 1. In the second term, you have 2 times 2 times 2, which we know is 8. We have an A and a B that we didn't circle. And in the last term, the only thing we didn't circle was a B. So therefore, that would be our answer. Same concept again. Here we go. 6c squared d squared equals 3ec cubed d to the 4th and 9e. The better you get at this, the more likely you can just look at it and kind of tell. 3 times 2, c squared, 2 c's, d squared, 2 d's. 3 is just 3 times 1, or just 3. E. C cubed is 3 c's, d to the 4th is 4 d's. And 9, I can break that down to 3 times 3 and then an e. So what do they all have in common? They have the number 3 in common. And what do you know? That's it. That's all they have in common. So 3 is their GCF. 3 goes for the rewrite on the outside of the parentheses. I'll have a minus and a plus sign on the inside. What we didn't circle on the first term is the 2 and the c squared d squared. In the middle term, there's a lot of letters we didn't circle. We have an e, c to the 3rd power, and d to the 4th power. And in the last term, we didn't circle the 3 and the e. So that would be our final answer. Alright, last one. Notice it has 2 terms. I have 8, e to the 4th, f to the 3rd. and 20 g squared e f to the 5th power. All right, let's break them down. 8 is 2 times 4, but remember 4 is really 2 times 2. I have 4 e's and then f to the 3rd, 3 f's. All right, what about 20? 20 can be 4 times 5, right? So 5 times 4, but 4, remember, is 2 times 2. I have g to the 2nd power, so that's g, it's 2 g's, and e, then 1, 2, 3, 4, 5 f's. Now let's circle what they all have in common. What numbers do they have in common? They have the number 2 and the number 2. So 2 2's, I notice they have 1 e in common, and I notice that they have 3 f's in common. So my GCF is, well, 2 times 2 gives us 4. Then they have 1 e in common and 3 f's, f to the 3rd power. So remember, when we rewrite our whole answer, factored out, okay, the GCF goes on the outside. I'm going to have just a minus sign in the middle, okay, 2 terms. Everything we didn't circle goes on the inside. So the first part we didn't circle was the 2, 3 e's, so e to the 3rd, and that's it. The second term we didn't circle the 5, the g squared, the 2 g's, and then we have 2 f's left over, so f squared. And that would be our final answer.